Is it Marek Kotewicz? I don't know if you want to pronounce your own last name, but of the Parity client? Pardon me? Kotewicz? All righty. Well, thanks and good luck.
All right. Hello, everyone. So my name is Marek Kotewicz. So I'm one of the core developers at Parity Technologies, which is a blockchain development company. Before joining Parity, I was working for Ethereum Foundation since the beginning of 2014. So in this presentation, I'll talk a bit about the Parity Bitcoin client. That's a full node software written by me and my colleagues. And I'll also talk about a vision, Parity's vision of future for Bitcoin, Ethereum, and how those systems could coexist. Okay. So Parity Technologies, maybe a bit about the company. So right now we are about 25 people. We have several open source projects. The two biggest ones are Ethereum and Bitcoin clients. Our headquarters are in Berlin and London. Majority of people are based in Berlin at the moment. So the Parity Bitcoin team was just 3 people working on the node software for 6 months. We did not have any prior knowledge of Bitcoin besides the fact that like blockchain based cryptocurrency, and yeah. So PBTC is not a wallet. PBTC is a shortcut for Parity Bitcoin. It's a full node software, but without user interface. So there's just an API. You can use an API to publish the transaction to the blockchain. You can verify the transactions on your own machine, but there's no user-facing layer. Yeah, so it's written in Rust language. Rust language is a language developed by Mozilla. So Rust language version 1.0 was released in May 2015. I will talk about Rust language a bit more in next slides. So the client was designed to be simple. So the Bitcoin protocol itself is really simple. There are just those quirks and this edge cases, which makes like the whole thing really complicated to implement and complicated to verify that it's running correctly. It was designed to be reliable. Rust language is a low-level language that guarantees trade safety and a number of things that that lacks in old-fashioned low-level languages. It was designed to be modular. I will also talk about that a bit later. And fast. So Rust performance could be compared to C. And like PBTC, like initial implementation that we wrote, like without any optimization, is almost as fast as the core client right now. So what is Rust? Rust, so that's a quote from Mozilla webpage. Rust is a systems programming language that runs blazingly fast, prevents seek faults, and guarantees thread safety. So Rust was initially created by Mozilla to rewrite their web renderer. They've been working on this project already for, I don't know, 7 or 8 years. There's already a proof of concept of new Firefox using this new web renderer. And the first benchmarks are saying that the new web renderer is 6 times faster than the old one written in C++. Mostly because of the assumptions like that the language has. So like if your code compiles, it has to be thread safe. It's not possible to compile a code that's not thread safe. And that's a real, it's a huge advantage for a developer to be sure that his code is valid in this area. Oh, sorry. I pushed back. Yeah, so Rust features zero-cost abstractions, move semantics. So instead of copying the value, each time when we pass it to the function, the value is being moved. It's not the reference is not copied. It's just being moved. Guaranteed memory safety, threads without data races, thread-based generics, pattern matching type inference. Yeah, so Rust is like pretty modern, low-level language. According to Stack Overflow survey from last year and the year before, Rust is also the most loved language. So developers who use Rust currently are willing to use currently next year. So how did we start with Parity Bitcoin? So first we started with reading Bitcoin Core code, and that was quite quite horrible experience at first, especially that when we didn't know how it's working exactly. So then we started reading the docs. It was mostly Bitcoin Wiki. Thanks for them, really. They did an amazing job documenting everything. But what was really worrying us is this sentence, like is the first sentence in the wiki. The Bitcoin protocol is specified by the behavior of the reference client, not by this page. So at this point, we already knew that we'll have to look mostly at the implementation, not the wiki page. So we use other implementations. We also read the code of the other implementations that are known to be compatible with the core client. These were mostly libbitcoin, which is super readable, and libbtc, written in C. Then we wrote tests, run the code, write the code, run those tests. If they passed, then we were reading the core source code again. If they weren't, we also did that, and we're trying to fix the box. And we did this process in a loop like hundreds of times. So our observations, so on the left side, the cons, on the right side, the pros. So like the cons, so there's no technical specification, so it was like really difficult to, for example, write the code that verifies the block correctly according to all rules specified by the core client, according to all rules specified by BIPs. On the other hand, the protocol itself is really simple. So the Bitcoin protocol is like one of the simplest protocol I've been working with, but all of this small changes and the quirks make the implementation difficult. So the core is difficult to understand. There are hidden implementation flaws. Incomplete integration tests. So we've used Java, set of tests written in Java several years ago by one of the core developers, if I'm not mistaken. But what we've realized after running those tests, so all of those tests were passing, but still, like syncing the blockchain hanged like several times when we first started syncing with the blockchain, mostly because we had bugs in our code that were not, and like this bugs were, there were no test cases for those implementation bugs in the test cases. So it was yeah, it was kind of disturbing. Yeah, also the biggest con I think for current Bitcoin Core implementation is a very high entry point. So it's not really appealing for developers who are not super experienced with C++ and with blockchains to get to contribute to the core. personally think that it should be improved by having multiple implementations, because everyone should be able to write and contribute to the core code in a language that he's comfortable with. So we are trying to improve those few downsides in Rust implementation. So our code was designed to be readable. So if you look, for example, at verification layer of Rust Ppc, it's really clean. I think you could just by looking at it for 5 minutes, you know exactly what's checked during transaction verification, what's checked during block header verification, and so on. We are trying to avoid implementation flaws. I hope that, I think that we were successful in that, mostly because of the Rust language itself. So all of the, processing the transactions in parallel, it was easily doable thanks to Rust features. Same with monolithic code base. So our code base is really modular. And the entry point is also really low, maybe not really low, but much lower than the cores, mostly because the Rust is a language which is designed to be really readable. So we have this, you can use this functional patterns like pattern matching or working on monads to make your code look really readable. So the architecture of the client itself. So I divided the architecture into 3 layers, and those names are just basically names of the core crates. Crate is a name in Rust word for a library. So on the lowest layer we have core crates, which has some primitives, so block, headers, and so on. Sorry, it's in a chain. We have primitives for big numbers, for hashes, and so on. We have a layer. We have a library for serialization and for cryptography. So this base layer was really simple. It took us just a couple of days to write it. Then it's the middle layer is a script interpreter, all network messages that we support. Keys management, miner, and database. Those modules are much more sophisticated, and all of them are almost totally independent from each other, and they utilize just this base layer libraries. And on the top of that, we have peer-to-peer syncing rules and verification. So the verification model, in example, just uses script interpreter, keys, and I think a database to check the previous transaction outputs. Yeah, let's take an example. So let's say that we would like to replace the script and database libraries with something else. So we could easily take, libBitcoin consensus in example, and just create an interface matching our current script interpreter and replace those two. Same with database. Currently we use RocksDB. There is nothing stopping us from switching it to LevelDB, and it should not take longer than a few hours at most. So running PBTC, I will not talk about how to run the code. I mean, how to start the client. I will talk if you should run it. So we support Linux, Mac OS. Windows should also not be difficult to build, although I haven't tried that in a while. Is it safe? No, it's not safe, mostly because the implementation was it's just immature. It hasn't been done in production by anyone. Is it better than Bitcoin Core? It depends what's your benchmark. So I think if you if you look at reliability, like the Bitcoin Core is much better, mostly because it runs for years right now. Should you run PBTC? Definitely yes. So as I said, like by running PBTC or any other implementation, you make network more decentralized. I think decentralization is what's needed in Bitcoin world right now. So right now we have just majority of people running the core client, but if we had multiple implementation around, that would like help us achieve better security. So here, what's on this picture is actually it may seem unrelated. So it's like the first media parser written in Rust shipped in production. So this media parser is a parser written by Mozilla. So it was the first thing written in Rust that was shipped in production to millions of users. It was like several months ago. And because Rust was a new language and this media parser is a core browser, core part of the browser, they were really afraid of like running in production from the first day. Despite like majority, all of the test cases they had internally were passing. So what they did, they created a new version of the browser of Firefox with two versions of the same library. So one was the old library, old parser written in C++ that was parsing everything, and the other version was this new library written in Rust, and they were checking if hashes of the outputs were the same, and they realized that despite they had super test coverage internally, only in 93% of cases these outputs were the same, and the remaining 6% were like the Rust parser was just failing. So what they did, they fixed those bugs, and they released several more releases. And after some time, after they released then like the final version of this media parser, they realized that it was around billions of times, and none of the users had there was no bugs in this parser anymore, because after running billions of times, each time the output was exactly the same as an original parser. So what I think we should do to help decentralization is to do similar thing with Bitcoin. So if miners or just common users have a way to run multiple clients in the same time and maybe verify that those implementations produce the same outputs, that would help those implementations be, that would ensure us that those implementations are correct, and that would help us with client decentralization. Yeah, only running alternative implementation ensures network integrity. So the conclusions are, after writing the Bitcoin client, where Bitcoin protocol should not be specified by behavior of the reference client. That's my initial, that was my first impression, first conclusion. I posted here the screenshot of Ethereum's yellow paper. So Ethereum's yellow paper is a technical specification of Ethereum protocol. And some people think, majority of people think that it was designed before, it was created before writing the first Ethereum client, but actually it was not. So first, Gavin Wood, who was CTO of Ethereum Foundation, he wrote the first version of the Ethereum client in C++. And after he wrote this client, he already knew how the protocol should look like, and he described all of those things in this paper. And after like describing all of those things, he realized that like the client is not exactly what he wanted it to be. And he made some adjustments to the implementation and other clients as well. So they all, up to this date, like all clients implement this protocol and know, like how the transactions should be verified, how the blocks should be verified, and how to interact with each other. I think that it would be also really handy to have something like that in Bitcoin space, to have a protocol that specifies how the verification of the blocks is done, what are the network messages that are currently used by the core nodes. What I think might not be a good idea, and it came to me after discussing it with Andrew Stone at the lunch today, that there should not be a committee who decides what should go into Bitcoin or not. We should just come together and try to write, the technical specification of something that already exists. So it should be, like one-time event for writing a technical specification, proper technical specification of Bitcoin protocol. So the new implementations of Bitcoin could emerge easily. And so that's how I see it. So the protocol, and I'd like also to see some kind of tests that are, that could be run by all of those implementations. So we are sure that all of those implementations really implement the same set of rules. Going forward for Parity technologies. So at Parity, we used to be called IFCore, mostly because our area of interest was around here, so it was just Ethereum. Then we realized that our area of interest is not Ethereum only, but it's like blockchain space in general. So we changed the name of the company to Parity. We are working on the Bitcoin client as well right now. But what we would like to do in the future is to focus on like blockchain development in general, and not only blockchain development, but on this we call it Web 3.0. So that's the concept of like a network of multiple cryptocurrencies, blockchains talking with each other, and also some kind of other protocols connected to that. So IPFS, an example, that are able to provide a backend for decentralized applications. So there will be a decentralized application, which is downloaded from IPFS or hosted IPFS, and this decentralized application, the logic of this application is on one of the blockchains. Polkadot, I'll maybe talk about that later. Oh yeah, so that's how we see it. So that's basically our area of interest. So we believe that that all blocks are already here. So we just in Parity technologies, we are just trying to put those blocks together and create new technology out of it. So the green stuff is what we have developed so far. So there's like Bitcoin, Ethereum, has some smart contracts, proof of authority chains. We also have a WebAssembly interpreter, so it's possible to write smart contracts in any language compiled to WebAssembly, and later on these smart contracts could be run by some proof of authority Ethereum blockchain. I'll talk more about that on next slides. And the green, the blue things are the blue blocks are the things that we will be looking into in nearest future. So we'll work more on proof of stake chains, IPFS, and Polkadot. So Polkadot as a new project that will start soon. It's supposed, I would call it simply a blockchain of blockchains. So we want to do to connect multiple blockchains together. So you'll have Bitcoin blockchain, Ethereum blockchain, possibly other blockchains connected together with some kind of relay chains. You can think about them as some two-way pegs. So you'll be able to lock, I don't know, like your Bitcoin in some smart contract on a Bitcoin blockchain, and then use this Bitcoin, an example, like on Ethereum blockchain in some smart and like run some smart contracts logic written on in Ethereum virtual machine language. So that's the thing that we'll be working on. We'll start working on soon. And yeah, that's all from me.
All right, we're back on schedule. Does anyone have any questions? All right.
Yes.
Could you explain a little of the potential when like Ethereum and Bitcoin and all these other blocks are together in one system?
Oh, I think the potential is unlimited. Like, so you could basically design any system, because so Polkadot is gonna be just. So there's already a white paper about Polkadot at polka.io. So the paper already specifies in general how it works. Imagine that you have like Ethereum blockchain, Bitcoin blockchain. You know, like right now we could maybe create some kind of relay between those two blockchains. So you could manipulate with Bitcoin on Ethereum blockchain, but there's nothing stopping us with like developing another blockchain sometime in the future, which implements different set of rules or have I don't know some micropayments like on-chain micropayments or anything else that also uses Bitcoin. So basically, I think that there are no limitations right now. So Polkadot will be just like this relay network, proof of stake relay blockchain with no logic other than relaying transactions, and it will have an open interface, so everyone could connect another blockchain or a set of blockchains to that network. Including, you could also include some I don't know, like proof of authority, private chains, or anything like that.
Cool. So my understanding with Parity is that you really pride yourselves as being one of the highest performance Ethereum implementations. Is that correct?
Yes. It was like, so when we started Parity, we already knew the Ethereum protocol. We didn't knew Rust at the time. So what we were trying to do was to create, like we knew how the Ethereum protocol works and what are the which parts of the protocol are the bottlenecks. So we're trying to design the code to be as fast as possible, and Rust allows us, like to get like really enormous performance. Because I don't know if you've heard why Rust is called Rust. Because there's nothing closer to the metal than Rust.
Gotcha.
So
are you going to be following that same type of mindset and trying to push the boundaries with Bitcoin and possibly?
Yes, eventually, yes. So with Bitcoin, we started a little bit differently. So we knew Rust. We didn't know Bitcoin protocol. But to be honest, like it's not much different than Ethereum one. So like, of course, like different type of state transition. I mean, there's no state. There are just outputs and this kind of stuff. But we already knew how it should be, like what should be the architecture of the client.
Cool. Yeah. Look forward to seeing your contributions and hope that some of the other implementations can learn from all the hard work you're putting into it.
Thanks.
So since you know both blockchains intimately. Could you maybe reflect on the future of both platforms and where you think it's going, and when you're going to introduce your own new third road? Is that maybe in the books for the next time?
Okay, so right now, I think that the future is, so the Bitcoin was the first cryptocurrency, and it's the most valuable one today. And I think, and Ethereum right now is the runner-up for being the most valuable blockchain. And I think that this, regarding the price and the market, like that's the perfect solution. So like Bitcoin being the most valuable one, Ethereum being the runner-up, with like maybe more possibilities, but less expectations. So I don't know, although expectations are quite high right now. Nevertheless, I think that these two technologies could coexist. So I've heard it like several years ago that Ethereum is like a gold, and Bitcoin is like a gold, and Ethereum is more like an oil. So it just fuels the network, and I don't know. Regarding the Polkadot, we'll see. It's super early to say something more about that. So as far as I know, we are looking into like doing some kind of ICO. So because ICOs are like really popular recently in your space, yeah. And yeah, and the coin that would be eventually created would not be so the supply of this coin would be limited, and it would be used only to stake what's happening in the network. So the Polkadot network will be just a blockchain that relies the transactions, and people would vote with their stake on what's true or what's not. So, yeah.
Any more questions? I'm just curious, how far away, I don't know what even production ready means, but how long before Polkadot is production ready?
More than a year. So we just started working on proof of concept like last month, but it will be just a small proof of concept. But I don't know, like working testnet or something like that. I think we are looking into the end of 2018.
Great. Well, thanks so much. Good stuff.
Thank you.